Okay, imagine having an assistant built right into your web browser. And I'm not talking about just a search bar, but a real co-pilot, one that actually understands what you're trying to do and can take action for you. Well, this tech isn't science fiction, it's already here. And we're about to dive into how it's going to change, well, pretty much everything.
Think about it. An AI that can sift through your entire inbox and just give you the highlights or research a really complex topic for you, book your whole vacation, or manage your schedule. It can literally see what's on your screen and click where you would click. I mean, this is a total game changer for how we use the internet. But, and this is a big but, with all that power comes a new and pretty serious risk. Because what happens when that super helpful assistant, the one with access to your email, your calendar, all your accounts, is secretly taking orders from someone else? What if the websites you visit could actually turn your own copilot against you? Yeah, this opens up a completely new and uncharted attack surface. AI agents are incredible, but they also create a new kind of backdoor for bad actors. The threat has a name: prompt injection. It's basically a way of hijacking your AI without you ever even knowing it's happening. So here's the crucial part. Natural language itself becomes the weapon. An attacker can hide a malicious command right inside the text of a normal-looking web page, a blog post, a comments section, you name it. When your AI agent reads that page to, help you out, it also reads that secret instruction and gets tricked into carrying it out, completely overriding what you actually asked it to do. So, to figure out how to stop these attacks, researchers had to start thinking like the attackers. They really needed to break down these hidden commands into their most basic parts to see what makes them tick. And what they found is that every single attack has these three dimensions. First, there's the attack type. What's the attacker actually trying to achieve? Second, the injection strategy. Where are they hiding the command? And third, the linguistic style. How is the command disguised so it flies under the radar? Now check out this example from the research. It shows you just how sneaky these attacks can be. It doesn't look like a virus, right? It's disguised as this professional-sounding instruction that an AI might easily mistake for a legitimate task. It's a wolf in sheep's clothing, hidden in something as simple as a website's footer. And here's where it gets kinda counterintuitive. You'd think a command buried deep in a website's code would be the stealthiest, right? Nope. The research actually found that attacks hidden in plain sight, like invisible text in a footer, are harder to detect because they just blend in with all the other normal text on the page. So how in the world do you defend against an attack that's hiding in plain sight? This is where a project called BrowseSafe comes in. And the goal wasn't just to build any old detector, but one that was trained for the chaotic, messy reality of the internet, not some clean, sterile lab. See, the problem is that most security models are trained on really simple, clean-cut examples of attacks. But the real internet is noisy, it's complex, and attackers know this. They exploit it by embedding their commands in what's called high-entropy content. Think user comments or cluttered web pages where their malicious code can just get lost in the noise. To solve this, the researchers used something called hard negatives to train their model. These are perfectly safe, harmless bits of text that just happen to look like an attack. Like a privacy policy banner that says, "Important, ignore all previous settings," or maybe a code snippet with instructions. By training the AI on these tricky examples, it learns to understand true malicious intent, not just freak out over certain keywords. And the impact of a noisy environment is just staggering. Researchers found that by adding just 3 benign distractor elements to a web page, the detection accuracy of some models plummeted to around 81%. It just goes to show you how easily these systems get confused once they're out in the real world. Okay, so with this deeper understanding, the team went ahead and built a specialized model and a really robust security system. So, how did this new approach actually do against the threat? Let's take a look at the results. The results really do speak for themselves. This chart shows performance. Higher is better. And as you can see, the small, general-purpose models, they really struggle. Even the giant frontier models do okay, but the specialized BrowseSafe model, it achieved state-of-the-art performance. And crucially, it's fast enough to run in real time without slowing you down. But the researchers are really clear on this point. A single detector, no matter how good it is not enough. You can't just build a high wall. You need a fortress, with multiple layers of defense. And this is exactly that concept in action. The BrowseSafe architecture is a 3-step process. First, the fast model scans everything. If it's not sure about something, it flags it and passes it up to a more powerful but slower model for a second opinion. And finally, the system learns from every single one of those flagged cases, so it's constantly getting smarter and staying ahead of new attacks.
All of this really points to a bigger truth about the future of AI. Securing these powerful new tools isn't something you do just once. It is an ongoing, evolving cat-and-mouse game between the attackers and the defenders.
So what are the big lessons here? First, for specialized jobs like security, a focused model trained on the right kind of data will always beat a generic giant. Second, that training data has to be messy and realistic. Third, a layered defense is the only way to build a system that's truly robust. And finally, security has to be proactive. Always learning, always adapting.
And here's the really fascinating twist. While AI creates this whole new threat, it also happens to be our best weapon to fight it. Just as the source material says, AI allows security teams to find and fix these vulnerabilities way faster than was ever possible before. And this leaves us with a really critical question for the future. We are heading very quickly towards the world where AI agents are our co-pilots for almost everything we do online. The challenge for all of us is making sure that these incredibly powerful tools are built on a foundation of safety and trust right from the very beginning.